and welcome again to yet another episode of Blackboard. Today we're gonna look at the merge sorted array challenge. Basically, you're given two arrays. I'm gonna simplify this in this way. You have two arrays. Forget about the fillers. So let's say you have 1, 2, and 3. Okay, with this array, and you have another one, two, 5, 6. If we were to merge these two arrays into one array that is still sorted, sort of a merge sorter, okay? But this challenge, they needed you to use this same array to store the results, but we can leave that for the later, for the finalization. But for simplification, you can break it down into this. So if you have such a thing, all you need to do is have pointers at the beginning of each of these. Call this I and call this J, okay? And then you need to know what will be our final array length. It will be the length of num1, this array, calling it num1, okay, and num2. So this plus this is 6, so this array will be of length 6. Okay, and then all you need to do is compare I and J. So 1 and 2, which one is smaller? 1, so pick 1 and increment, go to the next I. Okay, so you pick this one. So let's start doing that. So you can pick this, put it here, increment this. Next time you're comparing 2 and 2, they are equal, so either of those can be picked. So if you check if 2 is less than 2 is false, okay, it will pick the others 2, which is still okay. So pick this and increment J. J comes here. Next time we're comparing 2 versus 5, and 2 takes it, so 2 comes here. I is incremented to this place. Now we're comparing 3 and 5. Yes, 3 is picked. It comes here. And now we are at the end of I. So in algorithm, you need to know when you're at the end and you should stop comparing. Because now there's nothing more to compare, and all you need to do is just take the rest that have remained, put them in their slots. So this is sort of a merge sort, okay? So my approach right now, and I'll leave you with one more challenge to go tackle this on your own. I'm not going to do all the work for you. I'm going to do this merge, and all I'll need, because the results needed to be in num1, so after doing this, I'll just copy over this into num1. Okay, I just copy them over in a one-to-one sort of mapping. Just copy them over here and read, because the function doesn't need to return anything. But I want to give you a challenge. How can you do this without using an extra space? So here you're doing a space complexity of m plus n, where m is the length of this and n the length of this. So how can you do this without this extra space? That's your challenge. Okay, let's write the code. So our function is, we're going to call it merge, okay? So function merge. And the function, it takes in the array called nums1. That's the first array, and its length, which is m. And then nums2, and its length, which is n. Okay. So we have our i's and j's. Remember those up here, I and j. So we'll do let I equals to 0, so pointing at the beginning, and let j equal to 0, pointing at the beginning of nums2. And then our merged array, we'll create a merged array here. Let merged equals to new array. And for performance sake, you need to always initialize with the, if you know the length, if you have the advantage of knowing the length of an array, initialize it with the length of that array. Okay, really important for performance than doing new array. If you just did this, this means that you leave the compiler to do this for you, or the interpreter, and then it will be struggling with performance for very huge arrays. Okay, and then we have an index to track where we have reached on merged, so we call it 0. So this is the index we're talking about. This one is what we call mi. Okay, so mi keeps going next to, okay. And then when we are picking something, just for simplification, we'll just call this thing that we've picked, call it pick. Okay, just for simplification, so we don't write the same piece of code every time. So we'll have, say, let pick. Let's just be null for the time being, not anything. So while we mi is less than m plus n, so basically what we are saying is that this mi is going from here at the beginning to the end of this merged array. Because remember, the merged array had the length of m plus n. So while that is true, we keep going. So what we'll be doing is, first, remember when we were comparing the two, so we'll compare if I is less than, no, first these are guard. Okay, this is just to make sure that we are playing within the boundaries of I and j. So if this is true, so if the boundaries are true, if I is less than m and j is less than n, if this is true, then let's play. So if nums1, that comparison now that I was talking about earlier, if nums1 is less than nums2j, okay, if this is true, if this is less, so we're comparing between these one, the value here basically, and the value here. Remember that explanation earlier on, comparing those. If this is less, then we pick the less one. So pick equals to, we are picking nums 1i, but then we want to go to the next I, so we can pick it and increment at the same time. This is as good as saying pick equals to nums 1i, and then later on increment I plus plus. Is the same. So we pick this. What if it's the opposite? We pick the other. So else pick nums2, and again do the same thing, j plus plus. Okay, so that we pick it and increment the j at the same time. So, and then that's the end of these two comparisons. But that these cases where we've already reached the end of I, but j is still continuing. So we check else if I is less than m. This is like j, we've reached the end of j, but I is continuing. So if I is less than m is still within the boundaries, just keep picking the remainders. So nums 1 I plus plus. Okay, it's just the same thing that we have up here, but just in a different context. Then the else is when now we have reached the end of I, but we still have j's. You just pick the remaining j's. So pick nums2 j plus plus. Okay, and then once we are done with that, now that we have the picks, now we need to put whatever we've picked into the merged array. So remember our merged array, say merged had mi, which was 0. So the same thing again with merged mi plus plus. So we put the stuff in mi and then increment mi right after. So equals to pick. This is just a shorthand trick. All right, and then that's the end of our while loop. So at this point we are here now. At this point we are here. We are here now. We have everything placed. So the remaining part is just to copy over the things into num1. Okay. So copying the stuff into num1 is just as simple as just a one for loop, just copying things over. So we just do a for I equals to 0. Remember I had already been initialized, so you can just make it I equals to 0 less than merged dot length. Actually for better, like sort of just for ISO sake, and that mi was our tracker, let's use mi instead. So reset mi back to 0, mi less than merged dot length. So we want to be true to sort of safety. So we say that basically our pointer or our iterator for merge was mi. So let's just keep the iterator as it was. So mi plus plus, and then nums. Basically what we're just saying, nums1 mi equals to merged mi. So just one-to-one mapping of copying over stuff, and then the end of our function. It's the end of our function. So that is it. Let me try and zoom it in. You can see it in one go if you want to do that. Yeah, so that's it. You can pause whatever you want to, and if you have more questions, always hit me at the comment section, or always send me an email if you want. At my email is, as we said earlier, just send it to ask@bored.black, and we'll be able to get back to you. Looking forward to hearing from you. Thanks, and see you on the next one.